Why is everyone so quiet? What's going on? Is it 12:30 class, right? It's nap time. All right. Um, just a few things before we start. I've changed some of the things, the way that our Canvas works. I don't know if anyone's had a chance to take a look at that, but see if I can get Northwest Vista's website to come up here. Doesn't look like it likes me. What is it about every time I try and get into this, it never wants to work? I guess so. I'm just reading these headlines here. Uh, you gotta love Northwest Vista's technology, huh? At Northwest Vista's website. Okay, well look, I used to have our videos, right, and I changed it. So now when you click on them, and I changed it actually this morning. If you click on our videos for our class, it's actually going to take you to this page right here. And what it is a YouTube. It's basically a YouTube playlist that I've created. And on the right hand side, you'll have a list of the videos, and they're listed by day. So day 1, day 2, day 3 will be up there, and the dates there also. And this is just a lot more stable than what I had been using before. And you can watch it on iPads and things like that. So just be aware that they're out here. And if you're interested at all, you can also bring up my other playlists. If you go to, well, still don't know why this is taking a long time. How do you get to my playlists? Where are they? You just go to my channel, and everything's running very slow. Okay, this is my YouTube channel, and I have all my playlists here. And the reason why I'm mentioning this is because a while back, when I say a while back, like 10 years ago, I did some videos on factoring, solving linear equations, solving quadratic equations, like way back when I first finished graduate school. And I still have them, so I threw them up here. So if you're having any trouble with things like that, especially the factoring, you can go take a look at what I have there. So, and then there's other stuff there that you wouldn't even want to touch, like calculus and stuff, but all of the videos I have are now up here. Okay? FYI. Now, I was going to take attendance today by using Northwest Vista's website, but it's not working. So, oh well. We'll have to do a sign-in sheet. Who wants to do that? Volunteer. We'll start it over here. Just tear out a sheet. Just if you could, just put today's date, 9/4, on top. And you don't have to worry about telling me what class it is. I'll figure it out. Just put your name and pass it around. And all I need is your name. You don't need to like sign. Just put your name so I can read it. Okay, questions off of the homework. Anything that you want to discuss? I gave you an assignment last time. 77. You know, the other class asked the exact same thing. So let's take a look. We're working out of 8.1. So this is on page 529. And number 77 has square root of 36 s to the 7th. And the instructions here are to simplify. So what we talked about last time is that anytime you have a number and a variable underneath the square root, that one thing you could do is split this into 2 square roots using that property that allows you, whenever you have multiplication inside the root, to split it apart, and then look at these individually. And we like to work with the variable first. So s to the 7th power. What we said last time is anytime we have a variable to a power, we ask ourselves, how many times does 2 go into that number? So how many times does 2 go into 7? 3 times. So that means I'm going to do an s cubed, and then I have one s left over, right? So I leave that one underneath the root. Is that okay? Yes. Okay. Now you take a look at the 36, and you say, can I break it down? But wait a minute. 36 is a perfect square, isn't it? 6 squared. So what is the square root of 36? Just 6. So your answer is just 6 s cubed square root s. Is that okay? Now, the next problem I was asked about, 79, right? Okay, for 79, you have square root 24b to the 9th. I'm going to do this the same way. I'm going to split it into 2. And I ask myself, how many times does 2 go into 9? 4, right? 4 with 1 left over. So I'm going to have a b to the 4th, but 1b is still underneath the root. And now let me try and break down 24. So I think I'll do this on the side. Right? I'm looking at the square root of 24 now. 24, I'd like to see if I can come up with 2 numbers that multiply to be 24, and one of them is a perfect square. 4 and 6? Everyone agree? So I can rewrite this up here. The square root of 24 is square root of 4 times 6. I'm going to do another line, split that into 2 square roots. And the square root of 4 is 2. Square root of 6 is square root of 6. B to the 4th, square root of b. Now, the only thing really left to address with the square roots is, can you break the 6 down? 6 only breaks down to be 2 and 3. And so you can't go any further because neither 2 nor 3 is a perfect square. So we're done with that. But we're not done with the problem, because our final problem, anytime we have square roots, if we have multiple square roots, we want to put them back together, and anything else, put them together. So I'm going to place the 2 and the b to the 4th together to get 2b to the 4th. When I say put them together, I'm just placing them side by side. And now the 2 square roots, I can put those together and put those back underneath a single square root. So I'm using that property that says you can split roots apart and just using it backwards to put them back. Okay? I handed back your quizzes from last time. I did grade these. Let me see. Lucas, just come grab these if you came in. Lucas. And then Cassandra. Where's Cassandra? No Cassandra? Linda? Selena? Kevin? Oh, okay. And I only have Selena and Cassandra. That's it. Let me just say something real quick about the quiz now that everyone's pretty much here that's going to be here today. I was a little tough with that quiz because I wanted the steps. I think I made that clear. I thought I did. The most important thing was the steps. If you got the answer, great. But what I wanted to see was, can you follow the process? So if you skipped a step or didn't show any work for a step, then I took off. All right? And that's just kind of just to let you know what my expectation is. Yeah. Yes. If you can go from the line up here, square root of 24, right down to this, mentally, do it. That's fine. The thing about this is I'm trying to show all the detail I possibly can in case someone's not quite sure. You want to get to the point where you can go from that top to down here. That would be nice. Anybody else need to sign in? The only risk with going from the root 24 down to 2 root 6 is if it's wrong, then on a test I don't give as much partial credit, because then I don't see where the mistake is. And that's another thing. On your exams, I do give partial credit. So if it's wrong, as long as you have some work and I can identify your mistake, then you get something. Okay, any other questions on the homework? Anything else here?
13.
Okay, so back on
The 496,
496. Number 13? Now this is from a different section. It says h of t equals t squared minus 7t plus 12 over t squared plus 7t minus 8. Right? Now, in the problem, it's asking to find the excluded values, or, yeah, find any excluded values and state the domain. We never talked about stating domain. I just said find excluded values. So keep that in mind, that your answer may not match exactly what's in the back of the book because of the way I've shown this to you. So when I do this, I look at this and I say, okay, what would give me division by 0? That's what we focused all of our attention on, right? What gives you division by 0? So we look at the denominator, we take it, and we create an equation out of it, and we set it equal to 0, right? Any t value I pick that makes that equation true is something I don't want to ever plug in for t. So what type of equation is this? Quadratic. And so you have a couple options: factoring, AC method, quadratic formula, right? But again, I think I've said this a few times now in this class. I would expect that a student in this class could get from here to the solutions. I'm going to do this one by quadratic formula because I don't think I've shown you, we haven't done one of those yet, right? Quadratic formula. So I'm going to use quadratic formula. Now, as a reminder, the quadratic formula says this. If you have any quadratic equation that looks like this, ax squared plus bx plus c equals 0, the answers, the solutions, are given by this formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Has anybody never used this before, never seen it? First time? Does it ring a bell? Yeah? Hello? Does not? So you have not seen that, or it's been a long time? It's been a long time. Anyone else? It's been a long time? Okay. I need to know these things. All right? One of my classes a couple of semesters ago, I did a little test. I walked into a calculus class, first day, where everyone's very proud and they don't want to admit they don't know something. And I started writing all my graduate math work on the board. Turned around, okay, it makes sense, okay, yeah. And nobody in there knew what the hell I was talking about. But every one of them was just writing stuff down, didn't want to ask, didn't want to stop me, you know. And then finally I turned around and said, what the hell are you doing here? You know, I'm here to help you. You have to ask me for help. You have to stop me if you don't understand something. Right? That same thing goes here. If you haven't seen something, you don't understand a step, you stop me, right? So this formula is applied to any time we have an equation that looks like a quadratic. And the great thing about this formula is all you have to do to use it is identify 3 numbers: the a, the b, and the c. Once you find a, b, and c, you plug them into this formula, and that's your answer. So for our problem, keep in mind that instead of x's, what do we have? T's. but I can still identify the numbers in front of them. So what for us is the a in this problem? It's the number in front of t squared, which is 1. So I'm going to put a equals 1. What is the b for us? It's the 7. It's the number in front of the t. So b is 7. Positive 7, right? And then c for us is the number by itself, which would be negative 8. Now look, you could factor that, okay? I'm not saying you can't. You're supposed to be able to solve this equation however you like. I'm just showing you quadratic formula. So my answers are, okay, I'm ready to go straight to the answers. I'm not going to say x because x isn't our variable. I'm going to say t equals. Now let's go through this. What is negative b? Negative 7 plus or minus the square root of, now the b but squared. So take your b and square it. 7 times 7, 49. Minus 4 times, now what's a? A for us is 1. So here's what I'm doing. I'm doing minus 4. A is 1. So I put a 1 here. And then times c, but c for us is negative 8. Now, everything I have there, everything I have, the 49 minus 4 times 1 minus 8, all that's underneath the square root. And then divided by 2 times 1. Now it's a matter of just determining what this is. So watch the way I do this. I'm going to work with what's underneath the square root first. I'm going to leave the 49 and the minus sign alone. So I'm going to be working with everything to the right of the minus sign there, everything that I'm highlighting here in green. So what is 4 times 1 times negative 8? Not negative 4. What's positive 4 times 1 times negative 8? What's 4 times 1? 4. What's 4 times negative 8? Negative 32. So this should give me negative 32. I'm going to highlight it green, saying that's what that green up there turned out to be. But what was in front of it? A minus sign, right? So I'm going to put that in parentheses. All of this over 2. I'm rewriting everything again. Negative 7 plus or minus square root 49. Now, when you take a minus and you subtract a negative like we are here, it becomes plus, doesn't it? And then all over 2. What's underneath the root there? What's 49 plus 32? 81. And what is the square root of 81? 9. Is this okay? Now I'm finally ready. Once the square root's gone, I'm ready to get 2 answers. And the way this is going to work is that, you see this plus and minus? That means I have to look at, first, act like the minus isn't there and do it as a plus. And then act like the plus isn't there and do it as a minus. So I like to do it this way. I have 2 cases. This can turn out to be 2 things, when I use the plus and when I use the minus. So let's do the plus first. What's negative 7 plus 9 divided by 2? What's negative 7 plus 9? 2. 2 over 2 is 1. Now let's do the bottom. Negative 7 minus 9 over 2. Negative 7 minus 9 is negative 16 over 2. It's negative 8. Oh, I'm off the screen here a little bit. You'll see this? So my 2 answers are what? 1 and negative 8. Those are your excluded values. Meaning that that function is okay as long as you don't try and plug those numbers in. Now, in my opinion, if we were to have started back with the original thing, it was what? T squared minus 7t plus 8. Was that it, or the other way? But that was the bottom. Oops, and I have it backwards. It was plus and then minus, right? In my opinion, when we were sitting at this, I used quadratic formula, right? But if you know how to factor, this is so much easier to do it like this. T plus 8, t minus 1. And then you set each one of those equal to 0. And you get two answers. What are they? Negative 8 and positive 1. But I wanted to show you quadratic formula because it's something that you should be somewhat familiar with. Okay? We'll have more practice with quadratic formula. Trust me. All right. Did that address the question? All right. Anything else from homework? All right. Today what we're going to do is we're going to kind of pick up where we left off. In 8.1, what we still had not done is add and subtract square roots. And the way we're going to approach this is kind of weird. We're going to go back to like when we first learned about variables and adding and subtracting things. If I ask you what's 4 plus 7, everyone's like what? 22? What? 11, right? Now, that's because if you take two numbers and add them together, you get a number, right? But if I ask you to do x plus 7, what's the answer? Well, you can't do it, right? You can't put those two together. Why? Well, one of them is a variable and one of them is a number, right? And you cannot put a variable and number together like that because you don't know the value of x. So there's nothing this is other than itself. Same with if I say, what's x plus y? Well, if you don't know what x and you don't know what y is, then you can't put them together, right? This is just x plus y. There's nothing else to be done. So I like to think of it kind of like cats and dogs, right? You put two cats together, you mate them, you get a cat, right? You can do that. You put a cat and a dog together. Some dogs, some cats, they may go for that, but you know what I'm saying? I mean, you got to have the same thing before you can add two things together. Now, that's going to come into play because what we're going to look at now is trying to add and subtract square roots. So let me give you an example. If I take the square root of 3 and I say, hey, add to that the square root of 3, then I want you to look at these square roots like cats and dogs. Both of these are square roots, right? So that much they have in common, don't they? They both are square roots. But you also have to identify what's underneath the square root, the 3 and the 3. Those are exactly the same also, right? So these are two exact same species, if you want to say, right? Apples and apples, oranges and oranges, dogs and dogs. The question is, what happens when you put them together? So if I have a dog and I put them together, that's two dogs, isn't it? I mean, they'll make one dog, but let's get away from the mating thing, okay? Let's just think about two apples, right? Apple plus apple, you get two apples. So how am I going to get that answer from this? Yeah, it's going to be 2 square root 3, but where's that 2 coming from? There's a 1 in front of each of these that you don't ever write, correct? There's 1 square root of 3 plus 1 square root of 3 that gives you 2 square roots of 3. Notice what's happening is that we are not doing anything to the square root or the 3, right? We're not saying, oh, this is add them together, it's square root of 6. That's a very common mistake. Because what people will do is they'll say, oh, I'll take the 3 and the 3 inside and I'll add them together. It's not the way it works. Now, I'm going to erase this stuff on the left side. I want us to real quick compare this to something we've already seen. How is that different than this? That's multiplication. And how do we multiply 2 square roots? Can't we just put them both together underneath the root? Right? We were using that property backwards. We were actually starting at the bottom and splitting it into 2, weren't we? But now if you start with the 2 split, you can push them back together. What's the square root of 3? What's 3 times 3? 9. And the square root of 9 is 3. What I'm trying to get you to see is that what happens when you multiply 2 roots is completely different than what you get when you add them. You're looking at completely different things. With the multiplication, you're actually working with what's in them. With the addition, you're working with what's out in front of them. Got it? Okay, let's do something else. How about 2 square root 7 minus 5 square root 7 minus 3 square root 7? So when you look at this problem here, you are going to first identify what's the operation between these things. So do we have addition and subtraction here? We have subtraction. As soon as you see subtraction, you want to start thinking, do I have dogs here? You know, are they the exact same dogs, or what are we looking at? And instead of that terminology in the book, these are called like radicals. Like radicals basically means it's the exact same thing underneath the roots, the square roots. So I'm going to highlight this. I have a square root 7, I have a square root 7, and I have a square root 7. So these are all the same, and we're actually subtracting them. So to subtract them, what I'm going to do is I'm going to focus on the numbers out in front of them, and I'm just going to combine those numbers together. So what's 2, take away 5, take away 3? Negative 6? Everyone agree with that? Yes? Okay. So we get negative 6, but what? Square roots of 7. So again, it's the only thing that changed was what we call the coefficient, the number out in front of the root. The root 7 stayed the same. Now there's multiple ways to approach this. You can look at it as you're factoring out the square root of 7, but hopefully that's clean enough for you. Questions on that? Now, of course, it's not going to always stay this simple, right? It's going to be a little more involved. Okay, let's try this one. How about 6? I'm going to pick another one, sorry. How about 5 square root 27 plus 4 square root of 3 minus square root of 12? What operation do you see there between those? You still have addition and subtraction there, right? Okay, so if you have addition and subtraction with square roots, you have to have the same exact square roots, don't you? I mean, that's what I've told you. So let's look at these. Square root of 27, fine. Square root of 3 is not the same as square root of 27, is it? So I'm going to make it a different color here. And then we have square root of 12, which isn't even the same as square root of 3 or square root of 2. So we have 3 different square roots, right? So your instinct would be, okay, well then we can't add them together. But we've seen that you can take square roots and possibly break them down, can't you? So that's what I'm going to do on the line below this. I'm going to start doing some work. First, I'm going to look at the square root of 27. That was that first square root right here, right? You can break 27 down to be what times what? 9 times 3, right? And so you might need more time or, scratch work to get this. I'm just going to assume that you could do it, right? If you had enough time here. That breaks down to be square root of 9 times square root of 3. And what is square root of 9? 3, right? So we get 3 times root 3. So the square root of 27 is really 3 root 3. Fine. Now let's go look at the next one. Let's look at square root of 3. The square root of 3, can you break down 3? No, so square root of 3 is just square root of 3, isn't it? Can't do anything to that. And the last one, square root of 12. Can you break down 12? 4 and 3, good. And then that breaks down to be square root of 4 times square root of 3, which is 2 root 3. Is that all right? Now I want you to notice something about all these answers we got just now. Well, do you see? They all have root 3 in them, don't they? And what is the operation? What's the operation? Look at that 3 root 3. What's the operation between the 3 and the root 3? Right there. Multiplication. So there's really multiplication in there. And this 2 root 3, there's multiplication in here. Now that's important because of what I'm about to do. I'm about to rewrite the whole problem, right? So here it comes. I'm going to take this problem, I'm going to rewrite it. This is equal to 5 times the square root of 27. But what did we say the square root of 27 is? It's 3 times root 3, right? And that 5 that's sitting in front of the root 27, what's the operation there? It's multiplication. So I should put a dot right there in front of my 3 times root 3. It's not addition, right? It's multiplication. What would my next term be? Plus 4. Now square root of 3 we couldn't break down, right? So it's still square root of 3. But my last one is minus the square root of 12. What's the square root of 12? 2 square root of 3. Now we're starting to get everything to look like the same thing, right? All root 3s. The only thing that I want to resolve before we do try and add them is to take care of this multiplication out here. Why would we do that multiplication before we try and add? Order of operations, right? Order of operations, you're always supposed to multiply before you add stuff. So let's try and multiply this out. 5 times 3, 15 root 3, plus 4 root 3, minus 2 root 3. Now everything's the same. Root 3, root 3, root 3. Since they're all the same, 15 plus 4, take away 2. What's 15 plus 4 take away 2? 17 square root of 3. That's it. We're there. Y'all doing all right? Okay. Here's what I'd like to do right now. I'm going to give you 2 problems to work. I'm going to give you about 10 minutes to work them. I just want to see where everyone is. Maybe it'll help you wake up. I'll turn the lights on. You can start talking about your weekend, whatever. So try these. First one, 6 square root 32 minus 9 square root 2 plus 3 square root 18. Whoa. Second one, 4 square root 3x cubed minus 14 square root 27x cubed plus 6 square root 12x cubed. So the first one is just like the one I just did on the board. The second one, I didn't give you an example just like it. So let's see if you can extend upon what I've done, take into account what we did last class, see if you can get that one. Okay, you can work together, but I want to give you about 10 minutes, see what you can do. I will come around and answer questions. I'm going to pause the video real quick. Yes, I'm going to bring it back up. Hey, you know what? I just realized, oops. I paused the video